Hello everyone, welcome to next numerical of network theory. And the numerical problem is, in the given circuit as shown in the figure, switch S is changed from point A to B at t equal to 0. Find the value of I di upon dt and d square I upon dt square at t equal to 0. And this is the circuit diagram. Solution at position A, the steady value of current I0 minus equal to 100 upon 1000. This is 1 kilo ohm, so 1000 V upon R. So simplify this, we can get 0.1 ampere. The position B, I0 plus equal to I0 minus equal to 0.1. Then applying KVL, we have RIT plus LDI DIT upon dt plus 1 by C integration minus infinity to t it dt equal to 0. Then put the value of all R, L and C. This is equation 1. Initially capacitor is on charge and at switching instant capacitor behaves short circuit. That is the last terms of the left hand side of equation is 0. This is 0. Therefore 1000 it plus dit upon dt equal to 0. That is 1000 it plus dit upon dt equal to 0. So the value of I0 plus is 0.1. Then simplifying this, we can get di0 plus upon dt equal to minus 100 ampere per second. And differentiating 1, after differentiating we can get this equation and put all these value, we can get minus 1000 into this value is minus 100 and this is minus, and simplifying this value is 0.1, so you can get minus 9 into 10 to the 5 ampere per second square.